Hello everyone, this is Charlie from the Bloomingdale Public Library, and today we're going to be taking just a quick look at Cura, which is one of the applications we use to convert your 3D digital object files into something we can use with our 3D printers. First, just a quick word. This video is primarily intended as a promotion for our 3D print services here at the Bloomingdale Public Library, and the goal is to give you some insight into the process of bringing your digital objects into the real world. So go ahead and download Cura and try it for free, but when you're using our 3D print services, keep in mind we're going to do all the slicing stuff for you, and we are not accepting G-code files at this time. In other words, if you've got something you want to 3D print, send us the OBJ or STL files. If you wanted to learn more about our 3D print services, please visit our website at myppl.org/3dprint. Alright, so what is Cura? It is a free, open-sourced slicing application used for 3D printing. It is updated and maintained by Ultimaker, which is a 3D printer manufacturing company. And from what I understand, the software was originally written by just one guy, and Ultimaker went out and hired him on. This company also owns Thingiverse.com, which is a popular community-driven website for printable 3D models. And I think anyone that's done anything with 3D printing has probably heard of Thingiverse by now, but if you haven't, I'd recommend going and taking a look and seeing what other people have done. There's other websites out there that have the same kind of content, but I think Thingiverse by far is the biggest. Well, Ultimaker Cura works with a long list of 3D printer models with customization settings for anything that isn't listed. Some companies instead opt to customize the software for their own models. So if you look at the bottom here, we have Ultimaker Cura, and then on the right side we have Dremel Digilab, which is based on Ultimaker Cura. There's definitely a resemblance, and using one or the other is pretty much the same. The big difference is that Dremel Digilab will have all sorts of profiles and settings specific to their branded models. I called Cura a slicing application, so what exactly does that mean? Well, slicing software is what's used to prepare 3D models for 3D printing. If you didn't know, pretty much all 3D printing is building upon layers, and when you're working inside the software, I guess it kind of looks like slices, so that's probably where it gets the name. Preparing a model for printing includes applying basic transformations like resizing, rotating, maybe duplicating, also deciding what fill pattern you want to use and how much you want to fill. It also includes creating supports to build from. Since, like I said, you're building upon layers, so if you have an overhang, you can't just start building the overhang from space. You actually need supports to build up from, then you'd shave those off later. There's a few other things as well. Ultimately, what slicing software does is it takes a 3D object file and transforms it into G-code. And G-code is essentially machine instructions which tells the 3D printer what to do. Slicing software can also be used to monitor where you are in your G-code as your printer is running. However, it won't tell you if something's gone wrong. For that, you actually need to put eyes on your 3D printer. And we actually do have 3D printers now coming out with network cameras. And you can use apps to have a peek through your network cameras and even control your 3D printer to some extent to maybe stop it if something has gone wrong. Ultimaker Cura is available from ultimaker.com as a free download. If you're looking to try out slicing software, perhaps before purchasing your own 3D printer, this is a good one to try out because it does support several hundred different models of 3D printers, and if your model isn't directly supported, you might be able to customize a profile anyway. If you had your eyes on a specific model of 3D printer, you probably want to try their website first, just to see if they have their own proprietary software, but in a lot of cases it's just going to be a customized version of Cura, and if that's the case, you'll see maybe different coloring and branding and perhaps different settings and options specific to that manufacturer's printer models, but functionality will be largely unchanged. Now there is other software out there. One example is Prusa Slicer, which is also free and open sourced, and it's software that supports a lot of different models of 3D printer as well. It's considered more powerful at the expense of simplicity, so if you did want more control over your 3D prints, you might want to take a look at Prusa Slicer and see if it supports your printer. In case you were curious about what slicing software we're using at the library, well, that'll depend on the printer, and there's 3 of them. One of those printers is the Lulzbot Taz 6, which is a couple years old but already considered legacy on their website, and that just goes to show how quickly the industry is moving. For that printer, we use Cura Lulzbot Edition, and you can see what that looks like below. Again, besides the coloring and some of the tools being moved to different spots, it looks pretty much the same and functions the same as well as the other 2 we've already looked at. Next to that, you can see what Bamboo Studio looks like, and we use that for our brand spanking new Bamboo P1S. This printer is considerably faster than anything we've had before, and it's apparently capable of up to 16 colors, though we're not offering that yet. Even though this software is not based off Cura, you can see how similar it looks, and I imagine it functions pretty much the same, though I admit I haven't really put my hands on it yet. I mentioned we have 3 printers, and the other one is an older model Dremel, which runs off Dremel Digilab, which is also based off of Cura. However, I think we're in the process of phasing that guy out. Alright, so this is Ultimaker Cura. When you install, it's going to ask you whether or not you want to make an account. You don't need to do that. It's also going to force you to choose a printer model, which if you don't have one, just go ahead and pick one from the list. It's okay, you can always add more later. In fact, I recommend that you do, just so you can see how all the options differ from printer to printer. So now that we're here, just want to float through the menu really quick, just so we can see what's available to us. Under File, that's where you have New, Open, Save, Quit. There's also Export, which is one way to create our G-code file. Under Edit, again, familiar options, Undo, Redo, Select, Delete. Under View, we have camera positions, which are also available in the lower left corner. If you choose one of those, again, you can also use the lower left corner here. There's also Perspective and Orthographic. Perspective means things get smaller the further away they are. Orthographic keeps everything the same size. So if I choose orthographic, let's get another view here. You can see how the squares in the back are the same size as the squares in the front. Kind of plays with my eyes a bit, but this option does have its uses. I'm going to set it back for now. Under Settings, there's a couple things that are available in other spots, so we'll get to them later. Extensions, nothing I want to look at today. Preferences, just the one option here. Let's go ahead and select it. Under General, we can change the theme, so if you want dark mode, this is where you'll find it, but you have to reset first for it to take effect. A couple other checkboxes that are probably actually worth looking at, even at a novice level. And all the way at the bottom, we have the option for updates and privacy. It's up to you what you want to do there. Next up is visibility settings, and there are hundreds of these. So we're not going to go through them today. Just to give you an idea, just keep floating through, floating through, floating through. If you did have a particular level of visibility you wanted, you can also just go over to the right side here, choose Advanced, Expert, or All, and it will select a group of checkboxes for you. So if I choose Advanced here, you can see a couple checkboxes are automatically checked. We're going to keep things at basic for now. Under Printers is where you can add a new printer. Just go to Add New. I'm going to choose Non-Ultimaker Printer. And I'm not connected to the internet or a network right now, so nothing is appearing. So we're going to choose Add Non-Network Printer. Incidentally, we don't network our printers at the library either. We put things on flash drives and walk them over. However, that might change in the future since our new printer does have a network camera. So this is where we have the list of supported printers. Like I said, there's probably hundreds of models here. These are all the brands, and each brand has several supported models. We'll just pick one at random here. Let's pick one with a brand for more models. What you choose, just click Add. And there we go. It might also pull up a machine settings screen where you can have a look at some of the G-code that's added. nothing I really want to get into right now. If you wanted to delete a printer from the list, you just select it, choose remove, choose yes, and there we go. I do want to have a look at materials real quick. Depending on the printer selected, you'll have a list of supported materials. We will use generic PLA at the library. Over on the right side here, you can see some of the stats, density, diameter. If we go to the print settings here, they have the recommended temperature for the extruder and the build plate and a couple other things as well. You choose another material, you can see how they differ. If I choose a different printer here over on the left side here, you can see the Ultimaker 2 does not support nearly so many materials. And we'll leave that for now. Under Help, we have a whole bunch of online options here. Those are also available under these 9 dots over here. So I'm not connected to the internet, so I can't get to any of these, but some examples are the Ultimaker Support, Ultimaker.com, and the Marketplace. We also have a button for the Marketplace outside of the 9 buttons. If I click on that, again, you see I'm not connected to the internet, but it's a place where you can get plugins, materials, and things like that. I think you also need to be signed in. If I click on the sign in button, it tells you straight up, yep, this is where you can add material profiles, back things up, and connect to the Ultimaker community, which you can see on thingiverse.com as well. So that's all I'm going to cover as far as the menu and some of those options. Next, we're going to bring an object in and play with it a little bit. Okay, so let's go ahead and import an object. To do that, I'm going to click on the folder icon and select a file. I have an STL file here and an OBJ file. However, the spider was taking a long time to slice earlier, so I'm going to go with the person file and click open. Now you may or may not see what I just imported. However, if you look in the lower left corner here, you see sure enough we've got a person, and that person is 1 by 6.6 by 6 millimeters. In other words, it's really small. That's part of the reason we ask that you give us the model height when you make your submissions. It's just in case there's a scaling issue, we can go ahead and fix it. To move around in our 3D space, it's very similar to Tinkercad or Blender. You can use the scroll wheel to zoom in and out. Hold down the right mouse button to orbit, and then hold down Shift and the right mouse button to pan. So again, scroll wheel to zoom, right mouse button to orbit, and then Shift, right mouse button to pan. Now you can see what our little guy looks like. I'm going to go ahead and zoom back out. Select him. When an object is selected, it is outlined in blue. And because we have the move tool selected, we've also got arrows sticking out. So to use the move tool, all you gotta do is click and drag on the arrows, and it will move the object along that axis. If you try to move along the z-axis, you'll see the object drops back down to the build plate, and that's because we have drop-down model selected. If we uncheck that, sure enough, he stays in the air, but you probably don't want that. If something is hanging in the air, it's going to need supports, and that is both a waste of filament, plus it's one more thing you're going to have to shave off the model. So it's usually a good idea to leave drop-down model selected. If you want it to move more precisely, you can go ahead and type numbers into the fields over on the left here. So if I type in 20 for X, sure enough, the model will jump to X equals 20 on the grid. If we type in zeros, you see he jumps back to the center. So that is the move tool. The next tool is the scale tool. And when I do that, you see the arrows turn into cubes. So now if I click and drag on one of the cubes, the model grows. Now you'll notice he's growing in all axes here. That's because we have uniform scaling on. If we turn that off, then we can go ahead and grow in just one dimension. I'm going to go ahead and put that back on. Just like before with moving, you can also type in exact values. If that works better for you. The last tool I want to talk about is the rotate tool. I'm going to go ahead and select that. You see once I do, the object gets rings for all of the axes. So if you click and drag on any of the rings, the model will rotate along that axis. You might notice that I'm rotating in increments of 15, and that's because I have snap rotation on. If I turn that off, I can rotate freely. Generally speaking, I prefer to keep that on though. So a few other options here. If you choose lay flat, it will try to get your model flat on the build plate. If you choose select face to align to build plate, you click on that, then click on a face, and it will try to slam that flat on the build plate. So that's very useful for getting your model to lay flat, and it's a nice way to minimize the supports that you need for your model. Incidentally, I have trouble getting my rings back. So if I bounce around between the tools, that usually works. So something to be aware of. If you have red on your model, that indicates a part of your model that's going to need supports. And if your model turns striped like that, it means you are outside of the building area. Incidentally, our guy is yellow because generic PLA is selected for our filament, and that is yellow by default. If we were to choose another material, you see that changes its color as well. So the color is based upon the material selected, and you can change that material here. But like I said, we're exclusively PLA at the library. You can also change the nozzle size here as well, depending on what your printer model is. So that is all I'd like to cover for right now regarding the transformation tools over on the side there. With the object resized and centered on the build plate, it's time to have a look at the print settings. And you can see some of that in the upper right corner right here. If we want to see more of what's going on, we can go ahead and click the down arrow. When I do that, you see the first thing underneath print settings is the resolution. And that is a measure of how much detail the object has. To get more resolution, you need to shrink the size of the layers, which will also increase the length of the print time. If we have a look at another printer, you'll see we have a couple more printer options. For instance, if I go to the Ultimaker S5, we only have fast and extra fast options for the resolution, but then we also have this balanced engineering, draft, and visual set of profiles above that. If we were to choose another printer, like the Hellbot, we don't have those engineering or draft options, but we've got a whole bunch more resolution options. So again, these are profiles and they all depend on the printer selected. I'm going to go back to the Ultimaker 2 though. And for the Ultimaker 2, all we have are resolution options, and those options are normal, fine, and extra fine. If you jump around between them, you'll notice that the recommended print settings below all change as well. So we'll stick it at extra fine and have a look at the recommended print settings. If you want to know what these do, you can roll over each of the names and it'll give you a tooltip on the left. So for infill density, that is a measure of how much material is inside the object. If you want to bump that up, just a matter of moving the slider, and what that'll do is put more material inside the object, but it won't change the outside appearance. You may want to do that to add a little bit of weight or a little bit of structural integrity to it. I'm going to set that back though. You can do that by clicking this little reverse arrow right up there. The infill pattern is what the inside is going to look like. It's set to grid by default. Let's go ahead and change that to triangles. And again, we're going to get that warning that we are changing the recommended settings. Shell thickness, this is how much material is on the sides, top, and bottom of the object. I'm going to go ahead and leave those alone. And then below that is support. Now you might recall we've got some red on our object, so we need some support. Now I could rotate this guy and put him on his face and we'd be good without any support, but I purposely left him standing because I wanted to go through the support options. So I'm going to go ahead and toggle support on, and when I do that, you see we've got the support type, which is normal and tree. I'm going to put on tree because it's a little more interesting, and placement is everywhere. We can switch that to touching build plate, but I'm going to leave it at everywhere. Our final option is adhesion. Incidentally, it was a pretty big issue with our first printer where it did not have a heated build plate, and so we had to use a glue stick to try to keep the 3D model in place, and even that wasn't entirely successful. So now that the newer printers all have heated build plates, things stay in one place a lot better. We have a whole lot less failed prints. And this adhesion option can help boost that a little bit anyway. So with it on, you get something called a raft, which is just a flat layer beneath your 3D object. And if you turn that off, you'll get something called a skirt, which is just like an outline around anything touching the building plate. I'm going to go ahead and leave that on though. And with all these options covered, I'm going to go ahead and close it up and slice it. Depending on how big your object is and how complicated it is, the slicing process might take a bit, but that actually went pretty good. And now we can go on from there to the preview phase. So once the slicing is done, you can look in the lower right hand corner for a little bit of information. The print is estimated to take 3 hours and 5 minutes. I believe we're still limiting prints to under 8 hours. You can also see the model comes in at 8 grams. Just a reminder, we do charge for 3D printing based on how many grams your model comes in at, and it's just to cover the cost of filament, so it's not too bad. Go ahead and click preview to take us to the preview mode, which is a very colorful screen. We also have bars on the bottom and side. You see here it says 1003. It's because there is 1003 layers to this model. If I start clicking and dragging on the circle here, you see it kind of dissolves away the model. You can go from the bottom up as well. If you want to know what the colors mean, you can click on this bar here where it says color scheme, and it'll tell you. So we've got green for the inner walls, yellow for top and bottoms, orange for the infill there. You notice it's that triangle pattern that we selected. Red for the side shell, aqua for the helpers. Go ahead and close that up. If you click on the play button at the bottom here, you can actually watch the path of the extruder. So going through this can be helpful to see if there's anything goofy going on inside of the model, or maybe something's wrong with the supports, in the case that you have a print fail or something like that. Otherwise, there's really no reason to watch all 3 hours of the preview, so I'm going to go ahead and stop it and save to disk. As you see, we're saving as a G-code file type. So that's good. Make sure the file name is something relevant, and go ahead and save it. And again, as far as our process goes, we would then take that file, put it on a flash drive or an SD card, and stick that in the printer and let her rip. You might notice at the top here there is a monitor phase, and that's only if you are hooked up to a printer. If I click monitor, you see I get an error message. So with that, I think we've covered everything I was planning on covering. So I hope that was interesting. I hope you had fun. And I hope I got your interests up for 3D printing. And with that, I wish you a good day.